Good morning. My name is Anjali Jared. I'm from SMARC. I'm going to do number 7. Let me share the screen.
Okay. Then, Marys, remember we have 15 to 20 minutes, so try to be.
Okay. I'm doing number 7. It's a question of projectile. So let me read it for you. A bullet is fired from a point B, which is at the top of a hill. So let me do that. That's this. So we're using this as the top of the hill. So this is point B. It is 50 meters above the ground. The speed with which a bullet is fired is 140 meters per second, and it hits the ground at a point Q, which is at a horizontal distance 200 meters from the foot of the hill. So it's going to be yeah. So the initial speed is tangential. This is 140 meters per second, and this is 200 meters. So, as you can see from part 1 and part 2, the angle of projection is not known. So let me say let theta be the angle of projection. Let the angle be theta. So in this question, we're given vertical and horizontal distance. That means that we're going to use the second equation of motion. That's S equals ut plus a half at squared. So with the vertical distance, let's say that's the vertical distance is, no, we're going to start with the horizontal first because it will give us the expression for time. So x, which is the horizontal distance, is equal to the horizontal component of the initial velocity times the time. There's no acceleration in the horizontal component. So the the horizontal component is 200. The horizontal component of the velocity is 140 cos theta times the t, which is the time which we don't know. So as we can see from part B, from part 2, the time of flight is also unknown, and also the angle is unknown. So we're going to express this in terms of time. Time is equal to 200 out of 140 cos theta, which is equal to 10 over Now we're going to use the vertical component now. Y, which is the vertical component of the distance. The vertical distance is equal to the vertical component of the speed t, so y, t minus a half gt squared. So as you can see, the vertical is 50, but we're going to use negative 50 because it's below the point of projection. So it's negative 50 is equal to 140 sine theta. The t we have it as 10. We have it as 10 7 cos theta, so I'm going to replace it just immediately. Minus a half. The acceleration due to gravity is 9.8 times, sorry, what is it, times there, times 10 over 7 cos theta squared. So when we solve this, we have negative 50 is equal to sine divided by cos will give you tan, and 140 times 10 times, divided by 7 gives you 200. So this will equal to 200 tan theta. Okay. Then as we continue to this side, a half times 9.8 times 10 squared divided by 7 squared will give you 10. And the cos is also squared. We haven't included it, sorry, we put it here. For squared theta. So negative 50 is equal to 200 tan theta. We want to make it one unknown. Here we have 2 tan and cos. So I'm going to express cos squared in terms of tan. We'll first do that. So we'll first do that by bringing the cos as the numerator as sec squared theta. So negative 50 will be equal to 200 tan theta minus 10. We're going to use the identity of 1 plus tan squared theta is equal to sec squared theta. This is the identity we're going to use to place it here, so we have one unknown, tan theta. This is 1 plus tan squared theta. And open the brackets, I'm not going to open the brackets, negative 50, to go to 200 tan theta minus 10 squared, 10 tan, sorry, 10 tan squared theta. So when we bring everything to one side, we're taking 50 to the other side. So 0 will equal to negative 10 tan squared theta plus 200 tan theta plus 40. As you can see, this is sort of a quadratic equation with the highest power 2. So you can reduce it if you want, but I'm just going to go straight to solving the quadratic equation. So tan theta will equal to negative 200 plus or minus square root of 200 squared minus 4 times negative 10 times 40. Square root of that out of 2 times negative 10. So this will give us two values of tan theta. One value is tan theta equal to 20.1980, and another is tan theta is equal to negative 0.1980. As you can see with the question wanted two possible values of the angle of projection, and that's what we're getting. We're just going to use this angle straight. I know there's a confusion with this. If it was a horizontal projection, there can be two angles of projection, which gives the same horizontal distance, or the same range. Now for this one, if one angle of projection is theta, and the other one is alpha, you can say that theta is equal to 90 minus alpha. But I'm not going to use that here because this was on a cliff, and the range is up to this point. So that method will work if the angle of projection will give us this point. So that's when we'll use that. But we're going down, so we're not going to use that. We're going to just use the two values we have got here. So when we solve, theta will be equal to arctan of 20.198. So the first value of theta will be 87.17 degrees. So this negative means that if we have our quadrants here, this negative means that it's either in this quadrant or this. So we can't project it here and expect it to move this side. So it's obviously in this quadrant, this is the fourth quadrant. So theta will be equal to arctan 0.1980. This is equal to 11.20 degrees. So that's our part one. These are the angles of projection. This negative means that if this is the hill, it was projected downwards like that, with this as 11.20 downwards. Well, this one 87.1 means that it was projected like this, and they both give you the same vertical distance at the end. So part two is asking for, part two is asking for the two possible times of flight. So the equation for time was this, if you remember. So the two possible times of flight will be got from the two values of theta. So as you remember, t is equal to 10 over 7 cos theta. So our first t, I can call it t1, is equal to 10 out of 7 cos 87.17 degrees. And the second, let me say t2, will be 10 over 7 cos. Because it's in the the fourth quadrant, you can use a negative, but because it's cos, it will have no effect. It will be the same as having a positive because it's cos. So that T1 will be equal to 28.9344 seconds, and the T2 will be equal to 1.4563 seconds. As simple as that. Now part three, we're looking for the angle with which the bullet hits the ground. So since there are two angles of projection, you can choose any as long as the corresponding time is also chosen. So we're going to use the third equation of motion. This is v equals u plus at to find the final velocity with which it hits the ground, the final vertical and the final horizontal component of the velocity, so you can calculate the angle. So the horizontal, I'm going to use this angle, theta, 87.17. So the horizontal component of the velocity is equal to the horizontal component of the initial velocity, because there's no acceleration in the horizontal direction. So the horizontal component, remember, is 140 times cos of this angle, which is 87.17 degrees. And we shall get 6.9122 meters per second. We leave it as 4 dp for accuracy, so you cannot get crossed. The vertical component, By, equal to By minus gt. The acceleration is g, and it's in the negative direction, the direction opposite to the direction of projection. So the vertical component will be 140 times sine 87.17. So 7.17 minus the d, which is 9.8 times the time which you got here, 28.9344. This gives us a negative because the velocity is in, it is the ground in this direction. If this is the ground, it is the ground in this direction. And this is the, if I to draw axis there, this is the negative y-axis, this is the negative y-axis. So the velocity will be negative. It's negative 143.7. 279. Meters per second. So if we were to draw our diagram, it should be done with a ruler. Our velocity will be in this direction. Let me call it alpha. And these are, if this is v, the velocity, this will be the vertical component vy, and this the vx. This is the y-axis, this is the x. So our alpha, which is the angle which they want, will be equals to the upturn of the vertical component, which is, we're going to remove the negative, which is 143.7279 out of the horizontal component, which is 6.9122. So the angle will be 87.25 degrees as shown. Yeah, that's how we do the number. If you want to use this second angle and this second time, it will be in the same method. It will be the same way. But here in the angles, if you want to use a negative acceleration due to gravity, it will be a negative angle, the same. Let me do it for those who would want to do it. So we're taking theta as 11.20 in the fourth quadrant.
Okay, we can also leave it as homework for those who want to. Okay. Thank you, St. Mary's College, Chisubi.